Now, throughout this course, we learned a lot about React. We learned a lot about how to build React applications and which different features you can add there. But of course, up to this point, we only built and tested our React website locally on our local machine. We spent our entire time in this course on development. We just wrote code and tested it. And of course, that is the main idea behind being a developer. But ultimately, of course, when you build a website, when you build a React app, you want to push it onto some real server to expose it to users from all over the world. And therefore, this course section is about deploying React apps. In this course section, we are going to explore how you can move from development to production and how you can publish and expose your React app to users from all over the world. So how you can move your React application from your local machine to a real server. Now for this, in this course section, we are going to explore the different steps you have to go through as part of the deployment process and which pitfalls might await you. And specifically, we're also going to have a look at server-side routing versus client-side routing. And I'll explain what's up with that and why it is important. So how do you deploy a React application? How do you push it onto a real server? There are a couple of steps involved which you can go through whenever you deploy or redeploy your application. It all starts with writing your code, of course, and then with testing your code. And this might sound obvious, but of course you want to thoroughly test your application before you deploy it. You want to play around with it, test different things, see if you handle errors correctly, things like that. You want to make sure that you're shipping an application which is ready to be used. Then, as a next step, you might want to explore optimization opportunities. There are certain things in your code which you can optimize. Most importantly, you might want to look into a concept called lazy loading. And we are going to explore this concept in this course section. So that is another important part before you actually move your code somewhere. Optimize it. Now, once you're happy with your code, it's optimized and it's working, then it's time to build your app for production. And with build, I don't mean that you need to write more code, but instead we will execute a script which was written for us already, which is part of this React project we worked with throughout this course. A script which will then output a production-ready bundle of our code, which is minified and automatically optimized to be as small as possible, so that we get an output there which we can take like that and move onto a server, and will then automatically serve our users a highly optimized code package which is as small as possible, which of course matters because we want to ship as little code as possible to our users, because they will only be able to interact with our website once it's fully loaded. So shipping less code will load the app faster and therefore is better, and will be able to automatically generate such an optimized minified code bundle with a certain script, which we are also going to see in action in this course section. Now, once we get this optimized code package, which is ready for deployment, we need to deploy that package. And therefore, the next step is that we take that code, which is produced for us, which is based on the code we wrote, of course, and upload it to a server. Now, there we'll have different choices, different hosting providers which we can use, and I'll show an example in this course section, but you can really deploy it anywhere. I'll just leave a couple of notes on what matters there and what you should keep in mind when it comes to deploying your application. You will definitely need to configure your server or your hosting provider's offering, And I'll dive into this configuration together with you in this course section to make it crystal clear what matters here, what you should pay attention to, and how you do configure and ultimately deploy your code and your server correctly. Now, for this course section, I prepared a brand new example application. A brand new example application, which you find attached, where we fetch a list of dummy blog posts and can view the details of such a dummy blog post. And therefore, as you can tell, it is rather simple, but it is an application that does use routing, that uses React Router, and has a couple of routes set up, that has multiple page components therefore, and multiple separate components that are used in those pages. And therefore, we're using various features about which you learn throughout the course. But the application actually isn't too important. This section is about deployment, and it is about preparing this application for deployment as a first step. And for that, let's assume that we thoroughly tested that code. So we're happy with the code, we don't want to change it. The next step then is to optimize that code before we then finally build that app for production, so before we then finally produce the files that we will upload onto a server. And therefore it's this optimization step on which I want to focus in this lecture here. And when it comes to optimizing that code, we could of course look into techniques covered earlier in the course. For example, techniques covered in the look behind the scenes and optimization techniques course section. We could look into using React Memo and things like that. But that's actually not what I want to do here, even though we could do it. But instead, I want to introduce a new technique you should be aware of. And that would be lazy loading, which means that we want to load certain pieces of code only when it's needed. But what exactly is lazy loading and how does it work? Well, to understand lazy loading, it's important to understand how this project here will be built and served to end users without lazy loading. And for that, it's important to understand that we have all these import statements in our various files where we import code from other files into the file where the import statement was added. So for example, in this blog.js file, I'm importing use loader data from React Router DOM. And that simply means that when this component file here is evaluated by the browser, this code for this hook will be imported because this code is needed in order to handle this component, this blog page component, correctly. That hopefully makes sense. We, for example, must import the code for the post list component before we can use that component here in the blog page component. So all these imports in the end connect these different files. And when this application is served to end users, all these imports must be resolved before something's shown on the screen. That hopefully also makes sense. If all these code pieces depend on each other, all code must be loaded before something can be shown to the end user. Now, actually, when we later build this application, something we'll do in one of the next lectures, then all these imported files will actually be merged together into one big file. But even if that would not be the case, we would, as I just mentioned, have to resolve all these imports in order to bring something on the screen. Now, the theoretical problem with that is that, of course, this means all code files must be loaded before anything's shown on the screen. And for this simple application, that's no problem. It is a really simple application with only a few code files, so it's not a problem that we have to load them all. But of course, in more complex applications, in bigger apps with dozens or even hundreds of routes and components, that could be a problem. Having to load all the code initially will slow down that initial page load. When the user visits that website for the first time, all that code must be downloaded before anything's showing up on the screen. And therefore that initial load can take quite long and leads to a bad user experience. Again, not a problem for this simple site, but can be a problem for bigger sites. And that's exactly where lazy loading comes into play. The idea behind lazy loading is that we load certain components in the end only when they're needed instead of ahead of time. And therefore, even though it's not needed for this basic application here, as it is rather simple, we're now going to add lazy loading to it so that you learn how it works and so that you could apply that lazy loading technique to more complex sites as well. So how do we now add lazy loading? Well, let's say we want to load that blog page lazily, so only when we need it. The code for the blog page and all the code referenced by that blog page, so for example the code for the post list component, should only be loaded when we need it. So for example, when we visit this website and we land on the home page, we don't need the blog page code yet. We will only need it later once we navigate there. And at that point of time, once we navigate there, it should be downloaded. And that's exactly what lazy loading will do for us. So in order to load this blog page lazily, we first of all have to remove this import. Otherwise, it's always loaded. It's loaded eagerly, as it's called. So we must get rid of that. Then, as a next step, we have to re-add it, but in a way that it's only loaded when it's needed. Now, it's actually worth noting that with this import, we're not just importing the blog page, but also the loader. So we're actually importing two things which we should now load lazily. And I will actually start with the loader. So the loader is being used down there. And here, to load it lazily, we can pass a function to the loader here. So replace the loader from before with a different loader function. And that should be a function where we in the end call an import function. Now this import keyword is a keyword we of course saw plenty of times already. We use it to import files. But it turns out that you can actually also call import as a function, and in that case, it will import something dynamically, only when it's needed. Now to import, you pass a path. In my case here, the path to pages blog. And then import gives you a promise, because this is an asynchronous process which can take a bit longer because it must download the code after all, and downloading that code can take a short while. So import gives you a promise. We can chain the then keyword here. Alternatively, we could have used async await, but here I'll use the then keyword. And then what we get here is the loaded module, so the loaded file in the end. And on that module, I now want to return the loader function. And of course, that loader function should be executed. That loader function, as we know, then returns a promise which yields a response. And therefore now with that code, our loader here will in the end yield that promise which is yielded by that loader function. But all of that will be done by loading this lazily. So now this import function here will only be executed once the loader here for the blog page is executed. So only once we try to visit the blog page. Only then the blog file will be imported and this loader function from that file will be executed. That's what's happening here. With that, we're loading that loader function lazily, and that's the first step. The next step is to also load the blog page component lazily. Now here we could use a similar approach. We could set this equal to a function, so to a component function, which in the end returns the dynamically imported blog page component file. So we again reach out to pages, blog. And we know that in there, our default export is that blog page component. However, this alone won't do the trick, because this here is not a valid functional component. Because whilst you can write components as functions, after all, that is what we did throughout this course, a function is only a valid component if it returns JSX code or something like this. This function here, however, returns a promise, because as I mentioned before, import actually yields a promise, and that's not a valid React component function. To solve this problem, React gives us a special function which we have to wrap around this function. And that's the lazy function, which is imported from React. Lazy is executed and takes this function with the dynamic import as an argument. And now blog page can indeed be used as a component. So here, where I'm using it as a component, this code will now work again. At least almost. It will still take some time to load the code for this component, because that code has to be downloaded after all. And therefore, you must wrap this with another component provided by React, the suspense component, which also must be imported from React. Now we saw the suspense component before already. We already used this suspense component with React Router when we used defer in our loader. Suspense is basically a component provided by React that can be used by other things, other components, to wait for content to be loaded before actually rendering the content. That's a general way of describing it. And here suspense is used to wrap it around this lazily loaded component so that we can show a fallback, which is specified with help of the fallback prop on suspense, until that component code is there. So here we could say loading. With that, we're now loading this blog page component only when it's needed, and we show a fallback until the code is there. And we're also loading that loader code only when it's needed, and then we execute it right away so that we overall still load the data as required. With that, if we save everything, we can go back to our page, to the home page, and if we click on blog, that site still loads as expected. Now, if you reload on the home page, you can see how lazy loading works by opening your developer tools, and there go to the network tab. Make sure you clear the tab so that you have no requests in there. And then if you click on blog, you will see that actually here, it downloaded this JavaScript file here. This JavaScript file was downloaded dynamically. That was downloaded dynamically because we added lazy loading. And that JavaScript file, which was loaded lazily here, includes the code for the loader and for the blog page component. Now we can also implement lazy loading for the individual blog posts now. For that, let me first of all show you how it looks like if we don't have lazy loading for them. Here on the blog page component, if I now click on a single post, we just have a request that downloads that post data from the backend, but we have no request that would download the code for this component. So to see the difference now, I'll go back to the blog page. And I will now add lazy loading for this single post here as well. You can of course also try this on your own as a practice. Here I'll uncomment the import and then add my post page constant here, where I again use lazy to wrap it around a function, where I then call import and import pages/post. Now that's the first step. The second step is to also use the loader code lazily, and for that here I'll again pass a function to my loader where I call import as well and import pages/post, and then here I get my module where I then access the loader and execute that loader function. So now with that I also load the post page component lazily, and if we now save everything, we'll see the difference once we click on a single blog post here. Now you again see that the code was downloaded dynamically. However, now we're getting an error here. And we're getting this error because this params object is now missing in that loader, which we execute here. Of course, we get params by React Router in this loader function. And here we should simply forward that under a params key to this loader. Or we simply take that overall meta object, which we get from React Router, which contains this params key, and we forward this meta object here to this loader. That's, by the way, just one thing we have to do. We should also wrap suspense around the post page here, as we did it for the blog page, so that we can await the code for the component itself without issues. So here I then also add my fallback. And with that, with those changes made, if we save this again, and I go back to blog, clear my network tab, and click on a single blog post, now we see that this works correctly, and that the code for this file was downloaded dynamically. And that's lazy loading in action. Again, for this simple app, it's not really required, but it is a technique you should be aware of because it can be very useful when you're building more complex applications. Now that we learned about lazy loading and we optimized our code, therefore, we can move forward towards deploying this and we can start building our app for production. That's the next step we should perform before we finally upload the production code to a server. Now, this build step here is required because the application we're building is not the application we're going to upload, at least not like this. This is not the code we're going to upload. This is the code which we use during development. It's very readable, and it sometimes even uses features which aren't supported like that in the browser, like this JSX code. That's not supported in browsers. It must be transformed before we can upload this on a server that serves it to end users. By the way, here during development, when we preview this page, we also get a transformed version of that code. This development server, which we started with npm start, is transforming the code as we're writing it. So it's a live transformation process, so to say. Now, for uploading the code, we also want to optimize it, and we do this by quitting the development server and executing a different script. Here in this default project, which we get from create React app, it's this build script. When we run npm run build, we execute that script, and under the hood, this will produce a code bundle with highly optimized and transformed code, which is ready to be uploaded. So here I'll execute this. As you see, this now creates an optimized production build. And once it finished, it created that build folder here. And it's the content of that build folder that should be deployed to a server. In there, in that static folder, you have your optimized JavaScript file with those different dynamically loaded chunks for the lazy loading, but also with that main chunk that's downloaded initially. And that file contains all the code you wrote plus all the third-party package code you're using, including the React library itself. It's of course not very readable, but it's valid code that can be executed. So it's the content of the build folder that now must be uploaded. And that is indeed the next step, because in the next step we will now upload that code and deploy this website. So now that we built the app for production, let's upload it to a server. Let's deploy it. And when it comes to deploying our website, it is really important that a React single page application is a static website. It consists of only HTML, CSS, and JavaScript files, and maybe a couple of images. But it contains no code that must be executed on the server. Instead, all the code will be parsed by the browser and will be executed on the computers of our visitors. Therefore, we only need a static site host. We don't need any hosting provider that executes code on the server. Such providers exist, and for certain projects you need them. For example, if you're building full stack React applications, as you could be doing with my MERN course or the Next course or some other courses. But if you're just building a React single page application, you don't execute any server-side code, you just need a static site host. Now, if you search for deploy static site, you'll find many articles that walk you through possible deployment providers and processes. You'll find many deployment and hosting providers. You'll find blog posts and much more. And for this course here, for this section, I will actually use Firebase hosting, which is one of the many available providers. But it is a provider that makes hosting static sites pretty easy, and therefore it is the provider I will use here. Now, if you want to use Firebase hosting, you can visit their official documentation to learn all about it. But of course, we're going to walk through the steps together over the next minutes. But you will also need a Google account. So here I'll quickly log in with my account. And once logged in, we can create a new project. Now I'll name this project React Deployment Demo. The name, of course, is up to you. And then we can continue here. We don't need to enable Google Analytics. Instead, we can create the project like this. And Firebase is a service that offers many other services as well. It, for example, also offers services that would allow us to execute code on the server. But here, we're only interested in its static site hosting service. So let's wait for it to finish setup, which it did now. And now we can get started by clicking on Build Hosting. Now here we can get started with hosting a site, and we get this convenient walkthrough process which tells us exactly what we have to do. And the first step is that we install a tool that helps us with uploading our code to the Firebase servers. So I'll copy that command and execute that command here in my terminal. Now on macOS and Linux, you might need to add sudo in front of that for that command to execute successfully. Now this will install these Firebase tools on your system. And once they have been installed, we can continue with the next step, which is that we must log in with that tool that we just installed. Log into our Google account, because of course we need some way of authenticating our requests that are sent through that tool to Firebase to upload that code to our account and project here. So therefore I'll wait for this setup process to finish here. And once it's finished, we can execute this Firebase login command. Now this might prompt you for your username and password, and ultimately it should log you in successfully. Now once you logged in, you can run Firebase init to turn your local project into a project connected to a Firebase project, so to say. Now here, when you run this, you're asked a couple of questions. For example, which Firebase features you want to use. And here we got a broad variety of features we could use. I'm only interested in hosting here though, and specifically the option where I configure my files for Firebase hosting, not the GitHub Actions option. If I had space, this is selected, and we don't need any other features here, it's just that feature. So we can hit enter thereafter, and as a next step we want to choose use an existing project because we already created a project on Firebase. So I hit enter here, and then select that project which I just created. If it's not showing up here, you can of course also create a new project. Now as a next step, it's asking me where my files are, basically, that should be uploaded. And in my case, that's the build folder, so I will type build here. Not public, but build. It then asks me if this should be configured as a single page app, and we will choose Y for yes here, and I'll get back to this question later in this section. For the moment, let's just pick Y here and hit enter. And we don't need automatic builds or deploys, so I will hit no here. It then asks me if it should overwrite the existing build.index.html file, and we don't want to do that, so we choose no here as well. So that now initialized this project as a Firebase project and connected it to the backend. It gave us two new files, which basically established that connection to the backend and contain some extra settings for hosting this. With that out of the way, the next step is to run this command to upload our files to Firebase. So that's what I'll do here. I'll run Firebase deploy, and this will now upload the files from my build folder to Firebase. So let's wait for that to finish here. Here we go. And it also gives us a URL where we can visit our website. So if I now enter this in the browser, here we go. That's my website now hosted on Firebase servers. And it's working just as it worked locally, but now it's out there in the web for everyone to visit. Now, once it was deployed, here in the Firebase console, you could add a custom domain. And if you would want to get rid of your site, if you would want to take it offline, you can run Firebase hosting :disable in your command line. This would take your site offline and would make it inaccessible. Here I'll choose no, but that is something you can do if you want to get it offline. But that is how you can deploy your React website here, for example, to Firebase. So we did now upload our code and deploy the website. As a last step, I want to talk about configuring our project for deployment and one important gotcha you should be aware of. You might remember that when we deployed this website, we were asked whether we want to configure it as a single page application. And we chose yes. Now this is important, but why? Well, keep in mind that on that website we have navigation. We can navigate between different pages. We can move between these different routes. And what's important to understand is that this navigation is provided by React Router, so by a package that's part of our React project. And that code for evaluating the URL and loading different components executes in the browser. It's even called React Router DOM, so it's a client-side package. It's not executing on a server. I mentioned before, this project has no code that executes on the server. Now, why is this important? Well, it implies that when we click blog here, the logic for moving to the blog component is executed in the browser, not on the server. Now, clicking on links is one thing though. What if we enter a URL like the domain /posts? Then it also loads this blog page as it should, but we shouldn't take this for granted. Because actually, when you have your application deployed on a server and a user enters a URL in the browser, what happens technically is that the browser sends a request to that server. That always happens because the browser must request the website for which we just entered the address. Now, the server then sends back a response, which of course is in the end this React application. So the HTML file, but also the JavaScript code that makes up this application. Now, if we did not just send a request to the main domain, but maybe also to some path like /posts or whatever path we have on our website, then that path also reaches the server on this initial request. And by default, the server would try to find the fitting response for the path we requested in our request. For example, by searching for a folder with the name of some route or posts in our example from before. And of course, the server in this case would fail to find a fitting file because it doesn't have any server-side logic for handling requests with different paths. What the server should instead do is always return exactly the same HTML file and the same JavaScript code so that this path which we requested can be resolved on the client side by that JavaScript code we requested, so by our React app that's using React Router. However, as mentioned, the default behavior is not that the server always returns the same file. Instead, by default, it would look for a fitting file in a fitting folder based on the request we sent. And that's why we got this question whether we want to configure this as a single-page application. By answering this question with yes, Firebase set up some configuration, which is respected by the Firebase server, which basically tells Firebase to always return index.html no matter which kind of path we're requesting. So no matter what comes after our URL, Firebase will always return index.html, which then will always request the same JavaScript files. So this makes sure that client-side routing is used instead of server-side routing. So here everything works, but it is something to be aware of because other hosting providers might not ask you whether you want to configure this as a single-page application, and in such cases you manually must set up some redirection rule that basically forwards all requests to index.html. That's why it's important to understand the differences between client-side and server-side routing and why we have to configure it like this.